Alright, so today we're going to talk about reflections on the coordinate plane. Yesterday we talked about translations where they slide around the graph, but today we're going to talk about reflections where they're going to flip over either the x-axis or the y-axis. So they're going to be flipping somewhere on that coordinate plane. So let's fill in our vocab. A reflection flips a figure over a line of reflection. So that line of reflection is going to be one of the axes that it's flipping over on the graph. So it's a figure over a line of reflection in order to create a mirror image. Each reflected point of the figure should be the same distance from the line of reflection on the opposite side. So it should look exactly like one of these figures. Either it's going to flip over here would be the x-axis. Remember, this is always the x, and this is always the y. So when I look at this smiley face, it's flipped over this line of reflection. So this is the x-axis reflection. And then on this one, we always say that this is x and this is y. Well, these two smiley faces look like they're flipped over the y-axis of reflection. Alright, so we're going to move down to number 1. It says reflect the figure shown over the y-axis. Let's make sure we underline that or circle it or something, because you want to make sure you're reflecting it over the right axis. You don't want to, sit there the whole time graphing something and then realize you graphed it over the wrong axis. So we're graphing it over the y-axis. Remember, this is your y. So it's going to be flipping from here over here, like as if you close the paper and then it just made a perfect imprint on the opposite side over here. So first, let's just go ahead and count how many points away from the origin, or from 0 this W is, and then we'll go the exact opposite direction over here. So it looks like when I start here, I'm only 2 units out from W on this side, so I'm just going to start here again and go 2 units out the other way. And that's going to be W prime. I'm going to do the same thing with X and Y, so let's just do Y because we know that's pretty easy. So Y is 2 units out, so I'm going to go here the left side, and it's 2 units out over here. So I'm just reflecting all of those points, so there's Y prime. And then let's look at X. So X is 1, 2, 3, 4, 5, 6, 7 units out from the middle. So I'm going to go to the left 7. 1, 2, 3, 4, 5, 6, 7. Make a point, and that's my X prime. And then go ahead and connect those points. And you should see a figure that is exactly like what you were given, just on the opposite side of the y-axis. So once we've flipped that figure over the y-axis, we reflected it, let's go ahead and record our coordinates or our ordered pairs from the original or the pre-image over here that was given to us, and then we'll record the ordered pairs for the image, the second one that we drew. So let's just go ahead and start with our W point. So I'm going to start with W. And W, if I start from the origin, I count over my X's as 1, 2. And then I go up 1, 2, 3, 4, 5, 6. So W is going to be 2, 6. I'm going to do the same thing with X and Y. If you need to pause the video if I'm going too fast, you can. So you should have 7, 4 for your X value. And then for your Y, I go over 1, 2 units and up 2 units. So 2, 2. Alright, and let's go ahead and do our image. So remember, these are the secondary points that we drew in. So instead of it being W over here, this is going to be W prime. W with an apostrophe. This is our new point. And then let's figure out those ordered pairs for our new points. So I go left from the origin 1, 2 and up 1, 2, 3, 4, 5, 6. So that's a -2, I'm sorry. So if you go left 2, it's -2. And if I'm still going up, it's still +6. And then X prime, we go left 7 and then up 4. So if I'm going left 7, it's -7. positive 4. And then y prime, I'm going left 2 and up 2, so it's negative 2, positive 2. All right, so now let's look at the coordinates or the ordered pairs that we've just written in this table, and let's see if we can figure out if there's any kind of pattern or anything that you're seeing that might, help you figure out a rule for this reflection. What I'm seeing is that all the numbers are basically the same, except for these x values. It looks like after I flipped it over the y-axis, my x values changed. So we can write here, if we want to describe it, the x values became their opposite. And the y values, it looks like nothing happened to the y values. They didn't change or anything, so they stayed the same. And the reason it's very important for you to understand the opposite, we don't want to say negative, because what if this figure was the first figure and they still want it reflected, so I would have drawn this one, well then my new image coordinates would be positive. So it's important to say the opposite, because sometimes you may start with a negative value and you can't, change a negative to a negative. That would mean it's staying the same. So you want to just write the opposite. If it's going from positive, it changes to negative, or if it's a negative, it changes to positive. That's the opposite. So don't write negative, just make sure you say the opposit. And then how could we represent this, algebraically? Well, remember, we always start with x comma y. That's like the basis of ordered pairs and algebraic expressions. So we want to change that based on our description. Well, it looks like the x values become opposite. All right, so the opposite of positive x we'll just write as negative x. And then our y values stay the same, so we just leave it as y. So this would be how we would represent this algebraically for a reflection over the y-axis. So make sure you know somewhere in bold that this is a y-axis reflection. It's not going to be the same for an x-axis reflection. There's two different types of rules you have to memorize here. So pause the video if you need to, and make sure you have everything down before we move on to number 2. Alright, so we are moving on to number 2, where you're going to reflect over the x-axis. So let's underline or circle it or do whatever you want to make sure you know that this is an x-axis reflection. So here is our given triangle DEF, and we want to reflect it over the x-axis. Now remember, this is your x-axis. So we're not flipping it this way anymore. It's actually going to be flipped up. Or if it was up here, we'd flip it down. Okay, but it's always going to be flipped over this line of reflection. So if I'm going to redraw my triangle, I'm starting at D, and D looks like we go over 2 and down 2. Well, if I'm going to flip it, I just want to go up 2 right here, and that would be D prime. And then you're going to do the same thing with F and E. So F looks like it's at -7 over here. So I'm just going to flip it and go all the way up to +7. And that's my F prime. And same thing with E. E is at -7 and +7 over here. So I'm just going to go all the way up to +7 here. And that's my E prime. And then let's go ahead and just connect those points. Alright, so we have our new image, and I'm going to go ahead and record our ordered pairs or our coordinates for both images. Remember, this is your pre-image. This is the one that was given to you, that you started with. So I'm going to start with point D. D is at +2, -2. And if I'm going too fast at any time, you can just pause the video. We can, you have time to finish it. E is at +7, -7. and point F is at positive 2, negative 7. All right, so to figure out our pattern or any kind of rule that we can set up, we have to do the second image as well. We have to do our regular image that we just drew in. So the ordered pair for D prime would be positive 2, positive 2. For E prime is going to be positive 7, positive 7. And for F prime, it's positive 2, positive 7. All right, so if we want to describe any patterns found in the ordered pairs, we just have to look at if it went from the original and it changed to the new image, what kind of pattern or anything do you see that's changed? Well, if I look at my X values, they're still the same. Nothing has changed about them. But if I look at my Y values, it looks like we went from negative to positive. So I'm going to go ahead and say that the Y values became their opposite. And the X values stayed the same. Now remember we talked about before, we say the opposite, we don't say negative, because here these were already negative and I want to just change them to the opposite of whatever negative was. So now they're positive. So sometimes they could go back and forth. So you'd need to just say the opposite. We just want to flip the sign. And notice that this was an x-axis change and the y's change. So it's kind of like an opposite rule. So when you are flipping over the x-axis, your y value is going to change. And then same thing with your y back up here. If you're flipping over the y-axis, your x value will change. So it's kind of like an opposite rule. And if we want to write this algebraically, we always start with x comma y. And here, it looks like our x values stay the same. So if I'm rewriting it, I can just leave x alone. And then my y values become opposite. So we're just going to write it as a negative y. All right, and that's how you represent a reflection over the x-axis algebraically. Go ahead and you can fold this in half and glue this into your notebook, and then we can get started on the homework page, and then you'll have a quiz to check your answers. So go ahead and glue this in. You can fold it in half, glue it in your journal, and then move on to the next assignment.